In this video, guys, we are going to look at how to find the determinant of a only 2 by 2 matrices. This method only works for 2 by 2, only work for 2 by 2 matrices. Alright, we have a matrix that is A, B, C, D. And it says find the determinant of this matrix. First thing first, we're going to multiply A times D minus multiplying B times C. And then you get the determinant of matrix A equal the determinant of matrix A. So let's try another one. We have a matrix that is 2, 5, 6, 2, 5, 6, and 2 again, right? And they said this is matrix P, and they said find the determinant of matrix P. We are going to do the same formula as what we did up here. So we're going to consider the 2 as A, and consider this 2 as the D, and consider this 5 as the B, and consider this 6 as the C. So we're going to use the same method that we did up here. So we're going to say 2 times 2, so 2 times 2 minus the bracket. The reason why I bracketed 2 is the same thing as saying 2 times 2. Alright, so we're going to say 2 times 2 minus, because this is A times D, minus, same formula we're using, 5 times 6. So 5 times 6. Alright, so we're going to just simplify this down now and say 2 times 2 give you 4, minus 5 times 6 give you 30. And 4 minus 30 it give you negative 26, right? Because the old 30 you pay for is still owing 26. So that's how we find the determinant of matrix. So this answer is going to equal to the determinant of matrix P, negative 26. Determinant of this. Let's try one more. Alright. For instance, we have a matrix that has 1, 2, negative 3, and 5, right? Let's say find the determinant of matrix B, which is 1, 2, negative 5. Use the same formula up here. I'm going to look at this formula and say, just follow the formula. All you need to do is remember this formula in your head. A, D minus B, C. That's all with the determinant. Just AD minus BC, which is A times D minus B times C. Then you need to always remember that formula, because if you don't remember that formula, you're not going to know how to find the determinant of a matrix. So always remember this formula to find the determinant of a matrix. So we're going to say the same thing, A times D, which is 1 times 5 here. So we'll say 1 times 5 minus 2 times negative 3, which is B times C again. So 2 times negative 3. Put that down. And then equal. So we're going to say 1 times 5 give 5 minus 2 times negative 3 give you negative 6. Right? We have 2 signs here. So you know that a negative and a negative is give you a plus, a positive. So minus 2 minus sign give you a plus, and a negative and a positive sign always give you a minus sign back. So that in this case is a 2 negative, so we're going to write plus, change it to plus. And so 5 plus 6 is equal to 11. So the determinant of this matrix B is 11. Alright.
Now we are going to look at how to find the adjoint of a matrix.
So here we go. We have matrix A, which is A, B, C, D. Right? So to find the adjoint of this matrix, we're going to simply switch the D for A. So we're going to put the element D here and the element A here. So we'll switch them oppositely. Now we're going to switch the signs opposite, and then we're going to switch the sign for these two elements, B and C. So we'll put back B. We're going to put now negative B and then negative C, because we switch the signs of those two elements only. We don't switch them. We don't switch C up here. We don't put C up here and then B down here. No, we don't do that. We just switch the signs of these two elements. We only switch these elements, but not the signs. We don't switch the signs now. We just switch the elements. So if this is a negative D, if a negative D was down here, we'll put a negative D up here. And if it's a negative A down up here, we'll put a negative A down here. We just switch the elements. We don't trouble the sign for these, but we only trouble the signs for these twos. Alright, so let's give you our next example now. P equal 1, 5, 7, and 11, right? So we're going to find the adjoint of this matrix now. So we're going to say, we're going to switch these elements, the 11 and the 1 first. So we're going to switch, we're going to put 11 up here and then put the 1 down here. That's what I always recommending you do when finding the adjoint of a matrix first. So always do this first. Switch these elements first. Then we're going to switch the signs of these two elements. So we're going to put back the 5 and we're going to put back the 7. But we're only going to switch the signs of these two elements. So the 7 is going to turn, the positive 7 is going to turn a negative 7, and the positive 5 is going to turn a negative 5. And that's all you do in finding the adjoint of a matrix. Let's try another one. And this one you're going to try for yourself before I even work it out. So matrix B now, right? And matrix B is negative 1, 2, negative 3, no, negative 3, and 5, right? So try this one for yourself. Alright, now in order to find the adjoint of this matrix, we're going to do the same thing up here. So we're going to say, we're going to switch the 5 for negative 1 and negative 1 for the 5. So we'll put 5 up here, and then we're going to put negative 1 down here. Close the bracket, because of the matrix. So we're going to say now, switch the signs for these two elements here. So like when it's a negative 3, we know that it's going to turn to a positive 3. So don't write back negative 3 here. We just put a 3 that represents positive 3. Now, we're going to switch the sign for this 2, which is positive 2 right here. So we're going to switch it to be negative 2 over here. And this is finding the adjoint of not any matrix, but only a 2 by 2 matrix. This method only works for a 2 by 2 matrix. It can't work for a 3 by 3 matrix. It only works for a 2 by 2 matrix. Only 2 by 2 matrix. So thanks for watching, guys. Hope you enjoyed this video, and please subscribe for more.